Hey, fourth grade. So I learned something very interesting this past week about how your brains like to think about division. A lot of you really like to think about division being the opposite of multiplication. This is probably because you already know multiplication really well. So I had a friend who had a huge problem like this that they were needing to divide. And whenever I just see numbers, I don't know why, but I like to picture I like to put them with like a thing. So I'm just gonna pretend this is 6,583. Let's say imposters. What? And we have all these imposters, and we're dividing them between 7 rooms. Okay. I don't know why, but when my brain attaches these numbers to like actual things, it just makes a lot more sense for me. So maybe you want to try that too. Now, the friend I had who was working with a number really big like this, they were saying, well, I know that because I know my fact families, I can do 7 times something will equal the total. And I said, that's very true. Now, how in the world are you going to figure out what that something is? Now, can you pause this video and I want you just to take a guess what you think a number that we can multiply by that would get us close to this. Go ahead and pause this video and take a guess. Okay, so maybe you sat there and picked a random number and you did the multiplication. Or maybe you used what you already know and how you can multiply in your head. Like, for example, I know that it's really easy for me to multiply 7 times 5. I like multiplying by 5s. What is 7 times 5? That is 35. Are we close? No, we're not very close, are we? So times 5, that's way too low of an estimate. Now, what if I did 7 times, 9 is the biggest one. Well, I know 10s. Come on, Miss Childry. What's 7 times 10? 70. Okay, that's also way too small. How can I quickly pick a bigger number? Because I don't really know if I know how to multiply by numbers bigger than 10, just off the top of my head. Oh, wait a minute. I know my basic facts, and I know how to multiply times 10, so maybe I'm going to use that to my advantage. 7 times 100 is 700. Still too small. What about 7 times 200? Well, 7 times 2 is 14. Times 10, times 10, times 10, times 10. Okay, we're getting closer. We're getting closer. Now we're in the thousands at least. This is 6,000. Now 6,000. What 7 times what gets me close to like a number 6? Like 7 times 9 is 70. That's bigger. 7 times 5. 7 times. What's 7 times 6? How about, let's try 7 times 700. What is 7 times 7? 7 times 7 is 49. 0, 0, 0, 0. Okay, we're closer. Closer. What about 7 times, what about 7 times 800? What is that? It's 5,600. Okay, we're getting closer. 7 times 900. That's 6,300. Whoa, 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 whoa. Look how close we are. We are so close to the answer. Took us a minute, but we know that 900 is going to be pretty close to our answer. Now, my friend that I saw doing something like this, they actually wrote it kind of differently. They wrote 6,583, and they put a 7 here. And then they did this really weird thing. They said, okay, if I do 7 and I make 900 groups of 7, right? That's what multiplication is. It's groups of something in those groups. So 900 groups of 7, 7 times 900, that is what we just figured out, 6,300. Then they subtracted this. Why do you think they would subtract this number? Well, they would subtract it because they know that if they put 900, remember, these are imposters. If they put 900 imposters into each of these 7 rooms, that doesn't look like the word rooms, but that's okay. If they put 900 imposters into each of these 7 rooms, they just put 6,300 imposters into rooms. So when they subtract it, they found out that they still needed to put 283 imposters into 7 rooms. So instead of like continuing to guess and check, now they started doing, okay, 7 times what is going to get me really close to 283. So I kind of see like the number 28, and I know 7 times, what is it? 7 times 3 is 21. 7 times 4, that's 28. This is 2,800, so maybe I'll do 40. 7 times 40 would be 280. Now, how many imposters do we still have to divide? That's right, only 3. Now, can we evenly spread out those imposters into 7 rooms? We can't. This is a remainder. So we would have to decide what to do with those imposters. Either we boot them off the spaceship, or some of the rooms are going to have an extra. I don't really know. It doesn't really matter. But we know now that we have 3 left over. But wait, where's the answer? There's nothing up here. Where's my answer? Well, this was my dividend. The total thing I started dividing. I divided it into 7 rooms. Do you guys know what the answer is? Okay, so maybe right here, I put 900 imposters into 7, not 900 imposters, I'm sorry. In each of the rooms, I put 900 imposters in them. And then I put 40 imposters in each of the rooms. So the first time, each 7 rooms got 900, and then they got 40. So I made 900 groups of 7, 40 groups of 7. I think if I add these 2 numbers together, that would tell me how many groups of 7 I made, right? I made 900 groups and then 40 groups. So I made 940 groups of 7. So looking back at my multiplication, 940 groups of 7 would equal this, right? Right? Well, let's check. 940 times 7. 7 times 0 is 0. 7 times 4 is 28. 7 times 9 is 63. Plus 2, 64, 65. Wait a minute. That doesn't work. Did we do something wrong? Why doesn't this work? Shouldn't it work? I thought we solved it correctly. This is 3 bigger, or 3 more than this number. Can you figure out why this is 3 more? So maybe you're thinking, well, that 3 sounds familiar, right? We had a remainder of 3. And if that's what you're thinking, you would be exactly right. 7 times 940 does not equal this. It equals something very close, 6,580. This is still going to be our answer because we know that we have 3 left over, and we can't divide 3 imposters evenly into 7 rooms. So even though when we solved it with multiplication, our answer seemed a little off of the original, because we know the difference is smaller than this divisor, then we're good. So our answer is 940 with a remainder of 3. I thought this was pretty, oh, I'm sorry if you probably just couldn't even see what I was writing. I apologize, 4th grade, I am really struggling. I thought this was really clever, the way that this 4th grader solved this problem. And they didn't get stuck on, I don't understand a strategy like the standard algorithm. They used what they knew about multiplication to help them solve it. So if this something like this is something that works for you, you can totally do that. I want to show you the standard algorithm just so we can see if we get the same thing, and so we can get a quick review on how the standard algorithm works. So First, we're looking at the 6. How many groups of 7 can we make with 6 imposters? Well, we only have 6 imposters. We can't even make one group of 7. So I'm just going to kind of skip over the 6, and I'm going to look at it as not just 6, but 65. If we have 65 imposters, how many groups of 7 can we make? Well, we know 7 times 8 is 56. Is that close enough? No. What's 7 times 9? That's 63. So if we made 9 groups of 7, that would be 63. So we still have 2 left to divide. Now, using 2 imposters, can we make a group of 7? No. So let's drag down our 8. We don't need to drag the 5 down. We already divided that 5 with the 65. So 28. With 28 imposters, how many groups of 7 can we make? We can make 4. 4 groups of 7 gets us exactly 28. So now we have no imposters left to divide. Just kidding. We have these leftover 3 imposters. But again, we decided that we can't divide those 3 imposters equally into those 7 groups. So we just have a remainder of 3 in this problem. Okay. Did we get the same answer? Wait. Did we get the same answer? 94,940? What? Oh my goodness, Miss Childrey. You have to remember your places. So this was 900 times 7, which is 6,300. This was not just 4 times 7 is 28. This 28 is 28 tens. So this is actually 4 tens. So when I drag that remainder down, I couldn't divide it by anything. So I need to make sure, even though I couldn't divide it, I need to put a 0 in that place to hold its place, right? So I drag the 3 down. I can't divide 3 by 7. So I make 0 groups of 7, and that leaves me with, if I made 0 groups of 7, I didn't divide anything, that leaves me still with the remainder of 3. So be very careful, because sometimes when you use a standard algorithm, you can't start here, you have to start here. And sometimes if you land somewhere where you can't divide anymore, you might have to pay close attention to where your places are lining up and see if you need a placeholder 0. Now again, we can always check our work with multiplication. All right, guys, good luck with your math today. Be brave and bold and try whatever strategy you feel confident in. I will talk to you guys later. Bye.